Hello everyone, welcome back. So in this video we are going to discuss the next three questions, question number 5, 6th and 7th of the this May June 2020 series. That code is 33970933. So let's begin. So here's question number 5. By first expressing the equation this is equal to this as a quadratic equation in tan theta, solve the equation between 0 and 90 degree. So we'll convert it. Before that we can see it is theta plus 45, so we'll use the expansion of tan e plus b. So let's start, and it is tan theta into the tan theta plus 45 is tan theta plus tan 45 upon 1 minus tan theta into tan 45 is equal to 2 cot theta. I'll write as 2 upon tan 2 theta, and then we'll use the property tan 2 theta formula. It is 2 times tan theta, and so upon, so it will go in the numerator, and that is 1 minus tan square theta. I guess it is okay. Now we will cross multiply everything. So it is, or we'll simplify it one more time. It is tan theta times 1 minus tan theta in the denominator, because tan 45 is 1. We know that tan 45 is 1. So it is tan theta plus 1 is equal to 2 cancelled, and I got it as 1 minus tan square theta upon tan theta. So we will solve it. Before that, let me simplify it. Let me bring it on one side, and we'll get by cross multiplication, that is tan square theta. Tan theta into tan theta is tan square theta. I am multiplying simultaneously here. It is tan cube theta plus tan square theta. I multiplied here, and when you multiply this, we will get 1 into 1 into tan square theta, it is minus tan square theta. Tan into 1 is minus tan theta, and tan into tan is tan into tan square is tan cube, but minus minus plus, so it is plus tan cube theta. Now we can see these two got cancelled. And how can we cancel it? Because it does not include 0. So if does not include 0, so tan theta will never be 0. Any which way we can cancel it directly, even if it is 0. So now next is, I'll transfer everything towards this side, so you'll get 2 tan square theta because this is minus, plus tan theta minus 1 is equal to 0. So this is a quadratic in tan theta. Now we can put y is equal to tan theta, and then we will get it as 2y square plus y minus 1 is equal to 0. So now we will solve for this, solve for y, and we'll put y is equal to tan theta. So we'll use the quadratic formula. Y is equal to minus b, that is minus 1, plus minus root b square, that is 1, minus 4 to the 8 into 1 9, 4 to the 8 into 1 is 8, so it is plus 8 over 2 into 2, that is 4, and hence we got minus 1 plus minus root 9 is 3 over 4. So what we got, y we got it as minus 4 by taking minus 4 over 4, or y will get by taking it plus, it is 1 by 2, because 3 minus 1 is 2, 2 by 4 is 1 by 2. And so last we'll use tan theta. So tan theta is equal to minus 1, and from here tan theta is equal to 1 by 2. So from this we'll get theta is equal to tangent inverse of minus 1, and from here theta is equal to tangent inverse of 1 by 2. So we know that between 0 to 90, in 0 to 90, because theta is going to vary from 0 to 90, 0 to 90 theta will never be negative, tan theta is not going to be negative, so it is not possible. Otherwise, if you calculate, we can see it from here. If you calculate from the calculator, it is tangent inverse of -1, and it is -45, and -45 is not in the first quadrant. Even if you want to find in the first and second quadrant, then it is next angle is 180 plus theta, so it is 135. That also does not lie in the range. So next is tan inverse. We'll do the tan inverse of 1 over 2, and it is coming around 26.56, so 26.6 degree. And next angle will be 26.6 plus 180, so which is of course not required, so only solution for this is 26.6 degree. That is the solution for it in 0 to 90. I hope it is clear. Thank you so much. Let's do the next part. So in question 6a part, by sketching a suitable pair of graphs, show that the equation this has exactly one real root. So we can see here two graphs. One is y is equal to x to the power 5. Another is y is equal to 2 plus x. So we'll draw the graph, and we can always see that this line, if x is equal to -1, y will be -1, and if x is equal to 1, y is equal to 1, and it will of course pass through 0. So this graph will look like this. This graph will look like this, and suppose this is -1, so this point is going to be 1, -1 here. So this point coordinate we can write -1, 1, and if it is 1, so this will also be 1. So this point is 1, 1. And next is y is equal to 2 plus x. Y is equal to 2 plus x. So we can compare it with mx plus c, and we can see that this line is having y-intercept as 2, so it is 2 somewhere here, and from here the gradient is 1. So gradient is 1 means 2, we can say 2 up and 2 ahead. So it will be going to, suppose this is 4, so 4 and then 2 somewhere here. So we got 2 points, and then joining these 2 points we can draw the line. I'll draw it like this. We can draw it with the help of scale. It is very easy to take the help of ruler. And now we can see that this graph these two graphs intersect at only one point. So it intersect here. So since both the graph meet at, or meet not, it's, I think that would be a nice term if you use intersect at only one point, hence there is only one solution. So it means only one real root. So only one real root. I hope it is clear. So we need to draw the graph, and when there are going to be more than one intersection, then there would be so many roots, because we know that roots and intersection points are same. So let's do the B part. Show that if a sequence of values given by the iteration formula this converges, then it converges to the root of the equation in part A. So it is given that it converges. So if it converges, then we'll must get a root over there, and let's find out how to do it. So since it is given that it is converging, so we can take all these xn plus 1 as 1x, and we'll see if we get the what we get as the equation. So let it make it as x is equal to 4 times 4 times x to the power 5 plus 2 over 5x to the power 5x to the power 4 minus 1, and then we'll do the cross multiplication. We'll get 5x to the power 5 minus x is equal to 4x to the power 5 plus 2. So we can take it one side, 5x square 5x to the power 5 minus 4x to the power 5 is equal to 2 plus x. Now we can see, since this is converging and we are getting the same equation as we have in the part A, so it means they are going to converge at a same root, converge at the same root as the first one. So we can say that we can get this iterative formula from x to the power 5 is equal to 2 plus x. So that's why they are going to converge to the same root. I hope it is clear. Let's do the C part of it. In this we need to use the iterative formula. So first of all we'll write this iterative formula: xn plus 1 is equal to 4 times xn to the power 5 minus plus 2 over 5 xn to the power 4 minus 1. This is from the previous, which is given already, iterative formula. With initial value x1 as 1.5, to calculate the root correct to 3 dp, places dp, give the result of each iteration to 5 dp. So it is sort of easy, because if you have x1 as 1.5, then we can find x2 by putting n is equal to 1 in this iterative formula, and we'll get 4 times x1 power 5 plus 2 over 5 times x1 power 4 minus 1, and which is 4 times 1.5 to the power 5 plus 2 over 5 times 1.5 raised to the power 4 minus 1. We don't require to write these all thing, because we can do this with the help of calculator directly. So by calculator I'm calculating, it is going to be plus 2 upon, it is coming as 1.331619. so we need to write till 5 decimal place. So next is 19, so I'll write only 2. So now we can find x3. x3 will be like 4 times x2 power 5 plus 2 over wherever you see xn in place of this, in this iterative formula, we are going to use the previous value. So it is going to be 5 times x2 power 4 minus 1, and which in place of x2 we are going to put this one, and this answer is coming as 273,516. So it is 2. And in the same way x4 we can get, see, we require the answer correct to 3 dp, so we'll find out till it is correct till 3 dp. Next is going to be 1.2672, and next is 6, so it is 4, and next will be x5, and x5 is going to be 1.267168, so it is 7, and x power 6 we can say it is going to be same. We can see from here 1.26716 and 8, so it is 7 only. So we can see this is correct till 3 decimal places. So the answer is, we can say the value root x is equal to 1.267 till 3 decimal place. I hope it is clear. So let's do the next question. Here's the question number 7. Let fx be 2 over 2x minus 1 into 2x plus 1, and express fx in the partial fraction. Since they are in the linear product, so we can write fx as a over 2x minus 1 plus b over 2x plus 1. So we'll multiply, and fx is given as 2 over the same thing, 2x minus 1 and 2x plus 1. So I'll multiply throughout by 2x minus 1 and 2x plus 1. So left hand side will left with only 2, and right hand side is a times 2x plus 1 and plus b times 2x minus 1. So let's put x is equal to 1 by 2, x is equal to 1 by 2, then this will be gone. So we get a times x by 2, it is 2, so a is equal to 1, and put x is equal to minus 1 by 2, we'll get 2 is equal to, this is gone now because 2 times minus 1 by 2 is minus 1 plus 1 is 0. So b times this is minus 2, so minus 2 times b, and hence b value is going to be minus 1, and hence the last fx in partial fraction form is 1. So 1 upon 2x minus 1 minus 1 upon 2x plus 1. I hope it is clear. So let's do the b part of it. And the b part, it is saying using your answer to part A, show that this square is equal to this. So again it is like we simply need to put the values we got in the A part, that was 1 upon 2x minus 1 minus 1 upon 2x plus 1 and then whole square, and this is equal to, I'm starting with left hand side, we'll write it like this, and is equal to, it is a minus b whole square formula, we can use identity, and it is going to be 1 over 1 square, the first time square, it is 1 over 2x minus 1 whole square, plus, or we can say minus 2 times first term, that is 2x minus 1, into second term, that is 1 upon 2x plus 1, and plus second term square, that is 1 over 2x plus 1 whole square. So we got it as 1 over 2x minus 1 whole square minus 2 over 2x minus 1 into 2x plus 1 and plus 1 over 2x plus 1 whole square. Now from A, we'll write from A, we know this is equal to 1 upon 2x minus 1 over 2x plus 1. So we'll rewrite it as 1 over 2x minus 1 whole square minus 1 over, because it is plus 1, so minus is already there, so 2x minus 1, and minus into minus plus 1 over 2x plus 1, and plus 1 over 2x plus 1 whole square, and that is what? That is the right hand side, and hence showed. So let's do the C part, and hence show that this is equal to 2 by 5 plus half times ln 5 by n. So we'll rewrite the same thing because we have this complete thing which is given here. So we are going to rewrite it as 1 over 2 2x minus 1 whole square dx, first thing, and then minus again 1 to, sorry, it is 1 to 2 1 over 2x minus 1, again plus in, sorry, it is 1 to 2 1 over 2x plus 1, and at the last it is plus 1 to 2 1 over 2x plus 1 whole square, and it is going to be integrated here. So this is the left hand side is equal to, now it can, you can see it is 2x minus 1 square in the denominator, so in the numerator it is 2x minus 1 to the power minus 2. So we'll take the integration, simple definition of integration of the type ax to the power n dx, that is x to the power n plus 1 upon n plus 1, and then you'll divide by the differentiation of this. So it become 2x minus 1 to the power minus 2 plus 1 minus 1 over minus 1, and then multiplied by the differentiation, divide by the differentiation of this, that is 1 over 2. Next is, I'll put the limit afterward at the last. Next is 1 over 2x minus 1. So we can say that this is, let's say it is t. So if it is t, then 2x minus 1 is equal to t, so 2 dx is equal to dt, so 1 upon 2 you will get, and we can use the log. So it is ln modulus 2x minus 1. And in the similarly we'll get here, this is 1 over 2 ln 2x plus 1, and at the last the same thing which we got it there, it is 2x plus 1 to the power minus 1 over minus 1 into 1 over 2, and then we will put the limits from 1 to 2, and hence it is, I can take 1 by 2 common from everywhere. I'll take 1 by 2 common, and then what we got, and it is, I'll put the value afterward. Before that I'll simplify it more, and it is minus 1 over 2x minus 1. It is 1 by 2 is common already, so minus 2x minus 1 and ln 2x plus 1, so it is going to be subtraction means division, so we can write ln 2x minus 1 upon 2x plus 1, and we can remove this modulus because we know that in 1 to 2 it is not going to be negative ever. So next is this minus minus plus, so plus, so it become 1 upon 2x plus 1 simply, and from 1 to 2. Now we'll put the limits, 1 over 2, and upper limit will give it is as 2 times 2 4 minus 1 3, and minus ln 2 times 2 4 minus 1 3, 3 over 2 2 is a 4 plus 1 5, 3 over 5, and minus 1 over 2 2 is a 4 plus 1 5. And now subtract the lower limit, that is minus 1, that is 1, so minus minus plus 1 over 2 times 2, 2 times 1 is 2, minus 1 1, minus minus plus, so it is ln 2 times 1 2 minus 1 1 over 2 times 1 2 plus 1 3, and the last is plus 1 over 2 plus 1 3. Now we can see it is coming as 1 over 2. I'll scroll up a little bit. So 1 over 2, and we can see the like terms, 1 minus 1 by 3 plus 1 by 3 cancelled, so it is 1 minus 1 by 5. 1 minus 1 by 5 is 4 by 5, and minus, it is minus, it is plus, so division, so I'm taking minus common, and it would be ln 3 by 5 minus ln 1 over 3, and that is ln 3 over 5 divided by 1 over 3. So at the last we'll multiply by 1 by 2, it is 2 by 5 minus 1 over 2 ln 3 into 3 9 by 5, 9 by 5. So now let's compare what we require. We require 5 by 9, and here it is minus 1 by 2, so it can be written as 2 by 5. I'll take it as plus 1 by 2, which will make it as minus 1 here, and minus 1 make it as 5 by 9, and hence it is right hand side. What we have used minus ln x can be written as ln 1 over x. So I hope it is clear. This was the C part and the last part of this. So we'll discuss the rest of the question in the next video. Thank you so much.